Okay, so we've seen how to use noise and turbulence, and in fact any other texture for distorting parameters. But how do we deal with distorting something like, say, an image that has no parameters that allow us to do any distortion on there at all? Well, what we do is, rather than distorting the image itself, we distort the UV coordinates that are used to map the texture onto the object. Here's how we do it. I've got a sphere here with a Lambert shader on it. There's its render tree there. First of all, let's get an image texture onto there. I'm not going to use the image texture that's in this submenu here. I'm going to use one from the texture generators submenu. I'm going to use the image lookup. This and all of these textures here as well are pretty much identical. There are some variations, but they're pretty much identical to the textures that you find here in this submenu, which you're probably more used to, with the exception that they don't come with any tabs in the property pages for texturing. There's no UV or projection parameters in there at all. They're the kind of raw texturing, and they require, rather like the noise and turbulence nodes that we've been looking at up until now, they require that you plug your own UV coordinates into there from texture space generators. Let's go ahead and do it. Here's the image lookup, and if we open up the node there, you can see there's its coordinate input. Do with it exactly the same as we've been dealing with the noise and turbulence nodes up until now. Plug the output of that into the diffuse input of the Lambert shader. Get ourselves a texture space generator, a projection, and plug that into the coordinate there. Let's set that texture up to be correct. We've got no projections on this object yet, so we'll create a new one, and planar, I think XZ. Bear with me if it doesn't work. There, that's it. That's fine. Okay, so now how do we distort it? Well, the link between the texture projection lookup and the image lookup is where we get to the UV coordinates as they're coming through, and we use this node down here, a texture space controller, a 3D warp node. Plug that into its texture coordinate and plug the output of that back into the coordinate there. Now you'll see that it's already offset the texture there. The name of this node is a little bit misleading, as is the noise coordinate input here that we use to do the distortion. It's actually not necessarily a noise input. You can put anything that you want into there to move that around. It's actually an offset. It's a UVW offset, and you can see that here, with constant values in there from the sliders, it has just simply offset the texture map. There's an intensity and there's a scale value in there. The intensity controls the intensity of the distortion. If I bring that right back down to 0, you should see, yeah, that the offset has become 0. So it's a way of scaling these input values here, and the scale value does a similar kind of thing, but slightly different. This is an intensity offset, and this is a multiplication here. Okay, so how do we make it distort? Let's put that back up to 1 there, so that we've got a value in there. Well, we'll get our noise or turbulence node in exactly the same way as we have done before. You should be looking in the user application data path. I'm getting mine from the workgroup application data path. You can, for the sake of this, you can, for the purposes of this exercise, you can use either the noise node or the turbulence node. You'll get slightly different effects with either, but seeing as this is just a demonstration, it doesn't matter which one you use. I'm going to use turbulence, and I'm going to take that, and what I'm going to do is I'm going to plug it directly into the noise coordinate node there. It's put a color to vector converter in there to convert the RGB output from our noise node. Doesn't look like it's done very much there. Don't worry about that just for the moment. The reason why it hasn't is because we need to put a we need to give us some UV coordinates to our turbulence node, and we'll create another new one for that. A generator, a projection. Bring that down there. Plug that into the coordinate input, and there we've got some sort of weird distortion going on. That's not what we're looking for, because it's taken the default planar texture projection. These things work better, these particular nodes work better with a spatial 3D texture projection, so that's what we'll use there. And there, we've got some rather interesting distortion going on. Let's just speed that preview up just a touch and make it a little bit bigger. There, some quite interesting distortion going on there. We can control the level of the distortion, the amount of distortion in the 3D warp, simply by bringing down the intensity there. So we can vary it right from 0 distortion, there, where nothing's happening, to a little bit of distortion, to all the way up to quite a lot of distortion. You can animate that if you want, that might be interesting. And we've also got a scale value there which will give us, which will multiply the value up there as well. A slightly different way of manipulating the distortion. If you crank that right up there, got some quite interesting distortion going on there. Bring that down to something that's a bit more recognizable. And of course, you've also got some control in the turbulence node there as well. If I bring the value of the color right down to 0, then because the output from this RGB node here is going to be constant the whole time, as you'll see if I just quickly plug that into the Lambert diffuse input there, that's the output of the turbulence node there. You can see it's constant, so you would expect the distortion on the 3D on the image there to be constant right across the object. If I increase the value up to, say, there, and then go back and plug our image lookup texture back into the Lambert diffuse, replacing the noise that we were just looking at there, what you'll see is that the distortion actually bears quite a close correlation to the light and the dark areas of this noise texture here. There, what's actually happening is the offset the offset of the image, or the UV coordinates, I should say, will be greater where the noise image is more intense, and it'll be less where it's less intense. So that's how to distort images. You can use that as a method if you wish for distorting the ripple texture. There's no reason why you should specifically be limited to using straight noise to distort a single parameter. You can distort the entire image, or distort the entire image's the entire texture UV coordinates for the ripple, or any other shader using this technique as well. It's just that by using parameters you can get down to individual parameters and control them separately and individually. So that's how to distort images, or more correctly, how to distort UV coordinates for textures. Now, the final thing that I want to look at as a method for playing or using noise to manipulate textures is how to deal with color. Let's just pop over to another XSI that I've got here. Again, I've got a straight Lambert shaded grid here to talk about how we use noise to drive color, or how we add color to the noise node that we've been using up until now. Right, let's have a look at its render tree. There's our Lambert node there. Let's get a noise texture, and I'm going to use Turbulence again. I just prefer Turbulence to the noise. The Turbulence is prettier. What can I say? Okay, so take that and plug that into our diffuse input there. Give it a UV projection, texture projection there, and make it a spatial projection. Have a quick look there. Okay, so we've set up the base of our UV. Have a look at the node, at the property page. Beg your pardon. Okay, so unlike some of the other textures that we've been looking at earlier in this series of tutorials, we've only got one color on this node rather than the two. So although we can change the lighter areas and make them slightly bluer, we can't change the black areas. That you might think is a limitation, but actually it's not. It's considerably more powerful, in fact, and the reason why is that we can use this to drive a lookup table, so that we've got absolute control over the way the colour changes right from the dark areas of the texture right up to the brighter areas. Let's pump this back up to white. We'll use a gradient node to do this. Again, not the gradient node that's under this submenu. We're going to use one from the texture generators submenu down here, a gradient. There it is there. And the reason that we do this is because there's an extra input on here, which is, if we can find it in this huge, bear with me, if we can find it in this huge, there we go, there's a scalar input there, which is the input which allows us to use the 2D gradient as a lookup. Okay, that's a standard gradient in there. First of all, let's replace the turbulence node with the gradient node. Let's give it a texture space generator because of where it's come from and the type of texture it is. We need to do that. Plug that into there and give it a new XZ, I think. Okay, so we've got a grad there, and it corresponds to the sort of grad that you can see in there. Right, now what we need to do is, in here in input, we're going to change the input to a scalar input, and then we're going to take our noise and plug it into that input, and there. Okay, we're starting to see a little bit of noise going on there. Let me just play around with these with this grad in here. Right, we've got yellow at the top there, and it is gradating all the way down through to blue. If I play with some of these sliders here to try and bring the blue up a little bit higher into the range there, okay, and you can see we're starting to get more texture there. What have we got that we can do here? We can play around with the minimum and maximum there to change the range that it's coming into. Let's bring the maximum up to there. There we go, that's it. Okay, now, how does that relate? Well, what's happening is the intensity of the turbulence node there is being used as an index into the colour lookup table. So the gradient here is going from red, and you can see red there, right up through yellow to right up through the blues and the cyans to the yellow there. And if we take the turbulence output there and plug that directly into the diffuse node, replacing the gradient there, you can see that the dark areas there in the turbulence node correspond to the red in the gradient, and the lighter areas there correspond to the yellow. Let's put that back there so you can see how that works. There. Okay, there's the yellow in the highlight areas. So you've got a lot of control there, and you'll see as I change some of these, let's use some of these presets in here. There we go, there's something that's beginning to look like a marble. No, that's the spectrum that we started off with. Fire, there's a good fire in there, starting from blue. And again, so you can see how powerful that is. Here's one thing that works quite well. Let's go to a black and white, a straight grad, and that's mapping directly between 0 and 1 there. Let's see what happens if we add another node in there and put a very sharp gradient in there. There, okay. A very, very sharp fall off between the black and the white. As you can see, you've got a much sharper define there. So what that means is you've got more control over the way that the colour is changing across our turbulence node there. That's very, very powerful. It's great for doing marbles. It's pretty good for doing skies, in fact. If I change this, for example, this dark area here to, say, a blue, this is going to look dreadfully rough, so do bear with me. And this one here also to a similar kind of blue, and make it slightly puffy, and, oh, I don't know, there. The worst cloud in the world, but you can see the beginnings of what I'm talking about. So that's the final tool at our disposal when working with noise. It's also worth mentioning, of course, that you don't have to use noise in any of the examples that we've been looking at here. You can use any one of the other textures. You could use one of Softimage's fractal textures or a cloud texture. there are any number of nodes can be used to drive these things in the exact same way. It's just that noise in itself is generally so powerful that we've been concentrating on that. And you'll see just how powerful it is in the next video, where we're going to be taking a look at some examples, some real-world examples of textures, how they were put together, some of the thinking that went into putting them together. So anyway, that's how to use noise for building up textures.